Okay, so hi guys. So, I wanted to make a quick video over how to solve a system of linear equations in 3 variables using, it's called Gaussian elimination. This is not the same as Gauss-Jordan elimination. Gauss-Jordan involves matrices, so it's not, I really want to make that clear. It's not the same thing. Not exactly. So we're going to look at a problem, and so we're going to look at a problem here, and this is the problem that we're looking at, and I already did work this out. And this is how I believe that it's done, right? The idea is, and before we even get into the problem, the idea is that we want to have some sort of, kind of like a, how do I call it? Kind of like a triangular, kind of like this, right? Where it goes ax plus by plus z equals c. And then it's like, you know, gy, let me do gy plus hz equals k, and z is equal to some number f. You basically want it so that it kind of aligns, you know, as kind of like a triangle, and you'll understand what I mean when we get to that point at the very end. But we're gonna do a systems of equations, and this is the following problem that we have. So according to the textbook that I have here, we want to use Gauss-Jordan elimination, or I'm sorry, Gaussian elimination, or Gaussian elimination, something like that. Let's see, hold on. Give me 1 second, guys. Hold on. Oh, and actually, let me rewrite this with Gaussian elimination. Okay. Now, this is the problem that we have, and so what I want to do is I want to get it so that basically I get some number, so I get x plus y plus z equals ... I get, you know, ay plus bz equals ... and then z equals ... I want it to look like this. And so right now it does not look like that. And so what I'm going to do here is I am going to grab, so the first thing I'm going to do here is, let me see, hold on. I'm going to try to eliminate my x variable, and whatever that elimination goes to is going to go on my second equation. So basically, I'm going to eliminate my x variable. So here, obviously, the two more convenient systems that I can eliminate right away, like right off the bat, are these two. The idea is that you want to eliminate your x variable first. So number 1, eliminate x variable, not x-axis, x variable. So to do this, I'm going to grab these two equations here, this one as well as this one, So I'm going to grab these two equations, and I'm literally going to go ahead and just write them over here on the space down here. So we have 2x minus 3y plus 5z equals 16, and then 2x minus y, or I'm sorry, plus y, and then minus 6z is equal to negative 20. Okay. Now, like I said, I want to eliminate my x variable. So to do that, this is pretty easy. All I have to do is kind of multiply the top by a negative. So that'll give me negative 2x, and you're going to use distributive property here. Negative 2x plus 3y. And let me zoom in a little more. If I'm writing really small, guys, I do apologize. Let me try to negative 2x plus 3y minus 5z equals negative 16. So that is what goes there. And then we're going to add 2x plus y minus 6z equals negative 20. So again, the third equation is my original equation. This one. And this is new equation 2, which was, this is considered new equation 2 because I'm trying to eliminate my x variable. Now, when I do these two things, and actually let me just kind of like that. When I do these two things, my x variable eliminates, and I end up with 4y, so 3y plus y is 4y, minus 11z equals, and this is going to be negative 36. Yes. Huh. Okay, wait. Hold on, guys. I think that's it. I don't think it's... Okay. I don't think it's wrong at all. No. So then... Okay, so here, this is what's going to go in for my, when because obviously we want it so that, so this is going to go for equation 2, new equation 2. Because again, we want to follow this format here. So obviously, if you think about it, I have a y and a z, so obviously that's going to go in the middle. This part is going to go in the middle, right? So now my following system is going to look like this. So we're going to kind of rewrite it again. So x plus y plus z equals 7. And then we have the other one, which was 4y minus 11z. 4y minus 11z equals negative 36. And then obviously we still have the very bottom one that we need to kind of work it out a little bit to to get z by itself, because really we need to have z by itself. We need to get z by itself in order for this to work. Okay. Now for z, so what I'm going to do is I have 4y minus 11z equals negative 36. And what I can do is the following, and I am going to grab, let me see, I'm going to grab my my two original systems of equations. So basically what's going to happen is I'm going to grab my two original systems of equations, because that is what I got for, so I got negative 4y plus 11z, or I'm sorry, minus 11z equals negative 36, right? And I eliminated my x variable, like I said. But let me see, 1 second, guys. Hold on. I need to see what I did. So then this is kind of like elimination in a way. I'm gonna grab these two equations here. So then I'm gonna try to eliminate again my x variable, but I'm gonna do it with equations 1 and 3. So this is equation 1, equation 2, equation 3. And now what I have is the following. Hold on. So I'm gonna do x plus y plus z equals 7. And I'm gonna do 2x plus y minus 6z equals negative 20. 2x plus y minus 6z equals negative 20. And now, and let me rewrite that. Hold on, guys. Let me rewrite that really quick. Okay, so I'm going to eliminate, again, my x variable. And again, I do believe this is how you do it. Basically, we're just going to go ahead and do this. So we have negative 2x minus 2y minus 2z equals negative 14. And then we have 2x plus y minus 6z equals negative 20. So then we know that this cancels out, and then we have negative y minus 8z equals negative 24. Okay. Now, oh, actually, no, I'm sorry, negative 34, excuse me. Okay, so then what I'm going to do here now is I have these two different equations, so let me kind of just color code here. I have this one as well as this one here. So this is considered new equation 3, right? And now I'm going to grab those two equations. So I have 4y minus 11z equals negative 36. And then I have negative y minus 8z equals negative 34. So now I need to eliminate my y variable. To do that, I'm going to multiply this by 4. So then I have the following. 4y minus 11z equals negative 36. And then I'm going to get negative 4y minus 32z equals, and 34 times 4 is about 136. So it's going to be minus 136 here. So then finally, this eliminates, and I end up with negative 43z equals, and it was negative 172. And if I divide both sides by negative 43, this is going to give me z is equal to 4. So now I have found my z value. So again, the idea was to get it to this form, and I finally did that, because now I have x plus y plus z equals 7, which was, you know, ax plus by plus cz equals dot dot dot. That was the first part, right? So this was the kind of the first part here. And then I also had by, or it was, what was it? It was ay plus bz or something. I'll just put by plus cz equals dot dot dot. That was this one over here, which was this one, like that. I have it on that form now. And then finally I have my z equals dot dot dot, which was, or I'm sorry, z equals 4. So that was basically what I was saying about z equals dot dot dot. Now it looks like a triangle in a way, right? Because if you think about it, this looks like a triangle. Just, you know, it's not perfect, but you can kind of see the shape that it forms. So now we're going to use what is called back substitution to solve for y and z, right? So we know that z equals 4, right? So z is equal to 4, and we know that. So z equals 4, so then we have 4y minus 11z equals negative 36. And then finally what we're going to do is we're going to say 4y minus 11 times 4 equals negative 36. And then we have 4y minus 44 equals negative 36. And then finally we're going to just say plus 44 on both sides. You can also just divide both sides by 4, right? So you can say this. You can say y minus 11 equals negative 9. And then you just add 11. And you get that y is equal to 8, I think. I think so. Or not 8. Wait, is it 8? Negative 9 plus 11? No. 2, excuse me. Y equals 2. So then you get y equals 2, and then finally, we're going to do x plus y plus z equals 7. So again, x plus y, we got y, which is right here, plus z equals 7. And then finally, we're just going to say x plus, and we're going to do, so we have plus 2, and then plus 4 equals 7. So then we have x plus 6 equals 7, and then finally minus 6 on both sides, and we get x equals 1. So our ordered triple is 1, 2, and 4. And that is how you solve a system of three linear equations by Gaussian elimination. If I am doing this a little bit wrong, please do correct me. I did my best. I just don't, I'm hoping that's kind of how you do it. But, if there is something that I'm missing here, please let me know. Otherwise, I really hope this helps, guys. And also, with that being said, thank you so much for watching, and please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.